Matematika. Today we're going to do problems and solutions of 1.12, transformation of functions. Let's start with the first set. Describe the transformation necessary to transform the graph of f of x, that is the solid line, into that of g of x, which is the dashed line. So that transfer form here is the green dashed line. So let's describe the transformation. I can see here that this graph is reflected across the x-axis. So I could describe that as reflect across the x-axis. Okay, that's one thing we can describe. After reflecting, this is the point where the 0, 0 is located, and it is now, I will blow this up, it is now at this point. That is from 1 to 3. From 0, 0, it moves to 3 to the left. That means it is translated. There is a translation taking place. So translate to the left. How many units? 3 units to the left. Okay. Let's have the number 2. This is an absolute value graph, absolute value function graph. So the solid, this is the original graph, and this is the g of x, which is the dashed line. It looks that it has been compressed. Okay, so I would say it's compressed. This is compressed vertically because the graph is approaching towards the y-axis. Okay, vertically by a factor of let's look at this. From here to here, 2. Here to here, it's 2. By a factor of 2. And then it moves from here, it moves up. So it translates upward. How many units? 3 units upward. That's the translation there. Okay. Let's do the letter B. Graphical representation. So use the graph of f to graph g of x. All right. When we do this, the first thing we have to look at is there is a horizontal, because this is the x. There is a horizontal translation. That's negative. That means 2 units to the right. All right. So let's look at this. Let's say this point right here, 2 units to the right. 1, 2. I will use this point right here. Okay. How about this point? 1, 2, right here. I'm doing the first set, which is the 2 units to the right. And then how about this point? 1, 2. and this point 1, 2, and this point 1, 2 right here. So from the translation of 2 points to the right, this will become this. I will use this color. Then right here. Then right here. All right, that's the first one. Having translated to the right. And this goes up 4 up. That means this go to 4. I will use another color here. From this 1, 2, 3, 4. This will go up 4, 1, 2, 3, 4. And this point will go up 4, 1, 2, 3, 4. This point will go up 4, 1, 2, 3, 4. This will go up 4, 1, 2, 3, 4. And this 1, 2, 3, 4. All right, I'm going to connect. So this will be connect to there. Then, wait, what's going on here? So 1, 2, 3, 4. And this is 1, 2, 3, 4. It should be here, not this. Right? So it will go that way, this way, and I'll go straight. From here, it is 1, 2, 3, 4. Did I miss out something here? Oh, it should be here. 1, 2, 3. Did I okay, I'm checking if I mess out some points. Oh, there you go. I have it already. All right. So this is the new graph. All right. For this. All right. Let's do this. Let's do the other one. I will blow this up. What do we see here? Let's do the inside first. Horizontal translation. So I'm going to use this color. Okay. X plus 3, that means to the left. 3 units left. Take note, do the opposite of the, do the opposite of the sign. When it's plus to the left, when it's minus to the right. So I have here 3 to the left. So this point will be 1, 2, 3. All right. This point will be 1, 2, 3. Okay, I'll do this. This point will be 1, 2, 3 right here. This point is 1, 2, 1, 2, 3. One, two, three. Okay. This point will be 1, 2, 3 right here. So I'll make the connection there. Then I'll have it a curve here and there. All right. This is the horizontal translation. But you can see this, there is a reflection. Okay, so where is it? Where is the reflection taking place across the x-axis? So that means I'm gonna use another color. Okay, that means it will reflect across the x. So this point will do the reflection here. This point will do the reflection here. This point will do, that is to the 0, it will remain because it's at the 0 for reflection. This point will do a reflection here, and this point will do a reflection here. Okay, so this will be the graph after the reflection there. Right, so this is the new graph doing the translation in the reflection. Let's do the third one. Okay, do the horizontal translation, the one that is inside the parentheses. You have to do that first. It will be easier before you do the vertical translation. So this is minus, that means 3 units to the right. Okay, I'm gonna move 3 units to the right. This point will move 1, 2, 3. This will move 1, 2, 3. This will move, I'm gonna erase these small dots here. This will move 1, 2, 3. 1, 2, 3. This point will move 1, 2, 3 right here. And this point will move 1, 2, 3. Okay, after the horizontal translation, this is what's gonna happen. You have that. This is your curve. Right here. And then you connect and then have, okay, we're not done yet because we still have vertical translation. That means down 1 unit, vertical. So we'll have the final graph. I'm gonna use this color. 1 unit down, so this will go down. This will go down 1, go down 1. This will go down 1, and this will go down 1. All right, I'm going to connect the graph. There you go. So this is the new graph based on the function. All right, that's it. Simple as that. Once you see the one inside the parentheses, that's the one you're gonna translate first. Okay, let's do this. You have transformed the given function f of x as described and write the resulting function as an equation. Okay, I'm gonna change color. So the f of x is equals to x squared. So I think this is quadratic formula. So we have g of x. It is expand vertically by a factor of 3. So you start with 3 and translate down 3 units. Take note that our function is x squared. That means this x squared is expanded vertically by a factor of 3 and translate down 3 units. That means minus 3. And that is your resulting function or resulting equation. 2. F of x is 1 over x. Okay, so it's compressed horizontally by a factor of 2. So compressed horizontally, that means is the inverse of 2 is 1/2 because it's a horizontal compression. So that means 1 over 2, wherein the x has been compressed and then 3 units to the left. That means x plus 3. All right, that is how it has been translated. All right, f of x is the absolute value of x. That is the parent function. Expand horizontally by a factor of 2. So we can write g of x start writing the absolute value. Horizontal, that means 2 is 1/2. That's the stretch, horizontal stretch. So by a factor of 2 and translate right 1 unit. So right 1 unit, that means the x is minus 1 because it's to the right. Then translate up 3 units. So that means plus 3, vertically translated. F of x is the square root of x, compressed vertically by a factor of 3. So the g of x will be, we have the square root of x as parent function there by a factor, and it's reflected. So the factor vertically is 3. That's the inverse for that because we have reflected. So it's minus. Then let's do the square root. What happened to the x across the x-axis? Translate right 2 units right. So that means x minus 2 and translate down 3 units. So it's minus 3. Okay. Letter D. Algebraic transformation. Express the g of x in terms of f of x. Okay. We have this. F of x is negative x squared plus 3. And the g of x is equals to f of x plus 2. Find the g of x. So by doing that, we could make the f of x as equals to this, which is negative x squared plus 3. And then you add 2. All right. So simplifying, the g of x will be negative x squared plus 3 plus 2 and that is equals to negative x squared plus 5. Simple as that. Number 2, g of x is equals to 2x squared plus 3. So this x right here, we're gonna replace that. So that would be making the f of x as x plus 2. That would be 2 times x plus 2 squared plus 3. All right. Expand x plus 2 squared, that would be x squared plus 4x. That is the square of a binomial. 2 squared is 4 plus 3. Then multiply 2x squared. 2 plus 4x, that is 8x. 2 plus 4, that's 8, plus 3. So simplifying, this is the, find the g of x, would be 2x squared plus 8x. 8 plus 3, it's 11. All right. Function of x is equals to 2x minus 5. So g of x, we have a negative f of x plus 1. All right. We have 2, and then substitute the x for x plus 1. Then minus 5, because there is still a minus 5, plus 4. Okay, let's do this. Let's simplify. 2 times x, that's 2x. 2 times 1, that's 2, minus 5, plus 4. So negative 2x minus 3 plus 4. The negative would become negative 2x, negative would become plus 3, plus 4. So the g of x would be negative 2x plus 7. All right. That's it. Okay. Let's have E. Describe the transformation necessary to transform the graph of f of x into that of g of x. Okay. You are given these two. F of x is square root of x, and then it becomes, the g of x becomes negative 3 square root of x minus 1. So I'm going to start with that negative 3. So it expand, right? Because it's outside, it expand vertically. Vertical stretch. So vertically by a factor of, how much is the factor outside? By a factor of 3. And then you can see that negative. What does that negative means? It's a reflection. It reflect across the x-axis because it's outside the radical sign. Then what happened inside? We have this is supposed to be square root of x because that's the parent function. And then there is a minus 1 outside. So that minus 1, it translates down, vertically down, 1 unit. Okay? Let's do the description of the other one. You're given an x to the third power, so that is the parent function. So that it becomes the g of x is 3 times x plus 1 to the third power. So you can see this, it expands vertically. That means vertically because it's outside by a factor of 3. Then what happened inside? Translate 1 unit, translate to the left 1 unit because it's plus. So in its plus, it is moving to the left. All right. Let's do this. Numeric transformation. Use the table of values to answer the following. You're given the table of values for f. Let g of x equals to f of x plus 2 and find the g of negative 1. Okay. So that means we have the g of negative 1, so we can make that as f of negative 1 plus 2. So the g of x, what is the g of negative 1 here? Negative 1 is, look at the table, 18, right? 18 plus 2. So the g of negative 1 is equals to 20. Okay? Simple. Let g of x is f of x plus 2 minus 3. What is the g of 2? Okay, we'll substitute the g of 2 to the x here. So 2 plus 2 minus 3. That would be the f of 4 minus 3. So what is the f of 4 here? It's 0 minus 3. So the g of 2 is equals to negative 3. Okay? Let's have the third one. Let g of x equals the negative of f function of x minus 2 plus 1. Find the g of 0. So we have a negative f, that is x minus 2 plus 1. So we'll substitute a 0 for x minus 2. That is f, a negative f of negative 2. And what is that in the negative 2? That is negative 6. So we still have plus 1 here. So plus 1, that is equals to, and this is a negative, so this will become a positive, double negative. So this will become 7. So the g of 0 is equals to 7. All right, let's do this. Write the g of x. That's the dashed line. All right. Write the g of x in terms of f of x. That's the solid line. Okay, let's look at this. The dashed line is what we're looking for, and that's the one we are going to make an equation. Okay, what do we have here? Let's see. I'll be using other color. Okay, I'm gonna use this color. First of all, I could see that there is a reflection. Okay, because they are facing each other. So there is a reflection across the y-axis for that function. All right. And I could see from here to here, it moved to the left, to space. That means it is x plus 2, horizontal translation. But let's look at this, what happened. Because this graph, if we do a reflection, okay, I'm going to do a reflection. This reflects here, here, reflects here. 1, 2, 1, 2. This somewhat reflects here. So the reflection should be this. It should be that. But what happened is that it translates to the left. But how much is the movement or the stretch? Because it's stretch, it becomes big. Okay, so it is stretched by from here 1, 2, 3. It's stretched by 3. Okay, from here 1, 1, 2, 3. It's stretched by 3. Okay, let's do the second one. Okay, there is a translation. Okay, I'm gonna do this, g of x. So what happened to this dashed line from here? It went down here. So I would say that there is a minus 1, goes down. So what happened to the function? It has been what? Vertically stretched by 2, 1, 2, from here to here. Okay, so that means if it's 1, 2, the scale factor there is 1/2 of x. Okay, let's do this. This is the graph. This is an absolute value function. So it is now inverted. So there is a reflection. So the g of x there, it's reflected across the x-axis. Let me see what happened here. 1, this is the point. 1, 2, 3. It goes up by 3. I'm gonna write that. So our problem is what is happening on the horizontal line. How much did it move? It moved by 1, 2, 3. This is where the point moves. 3 to the left. So that would be x plus 3. Because it moves 3 to the left. Okay, well this. Okay, what's going on here? there is a reflection. All right, so where is the reflection here? Here is reflection. Here is a reflection of that. So what happened to that reflection? It will be g of x, that's reflection across, where is it reflected? Across the x-axis. So it will be negative of the function. Our question is what is going on? Where did it slide? Where is the reflection going on here? It slide 1 unit to the left. Let's say here 1 unit to the left and go down. So that is 1 unit to the left and move up +2. So if I do this, that's the reflection of that. Okay, so it will be +2. All right. Domain and range transformation. Find the domain and range of the transform function. Given the graph f has a domain of -1 and 3, okay, and 5 and 10. And the range is inclusive 5, 10. 5 to 10 inclusive. All right. So let g of x is 2, f x plus 3. Find the range of g of x. Take note, when we say range, we are talking about that x right there. So it moves -3. So our range would be, if we have -1 and 3, then moving -3 to the left, our new range would be a -4. 3 plus -3, that's 0. This is the new range. Domain, I mean. Sorry. Okay, let's go to the range. Our range is inclusive 5 to 10. Where is that movement? Right there, because of these two. That's vertical stretch, and the scale factor is 2. That means if we have 5, 10 times 2, that the new range would be, because we have a scale factor of 2, that would be 10, 20. This is the new range. All right. Number 2, given the graph has a domain of -10, 4, -10 inclusive 4, and the range is -3 inclusive -3 and 6. Okay, what's the condition here? There is a reflection across the x-axis, but our domain is twice. That means the domain is stretched. Okay? So what is twice when it's domain? It's horizontally, that means the scale factor is, instead of 2, that's 1/2. It's the reverse. So that means the domain would be negative 10, 4, but the scale factor is 1/2. So 1/2 of 10, that is negative 5, and inclusive 2. This is the domain. It is reflected. So when it's reflected, the x and the y are also inverted or switch. So it will now become, the positive 6 would become a negative, and the negative 3 would become a positive. This is the new range. What's the reason for this? Because of the reflection. Okay, let's have 3. Given the graph F has a domain of, okay, you have the domain of inclusive 2 and 5, 2 to 5, and the range is negative 2 to 8. Okay. What does it say here? 1/2. You have a scale factor of 1/2. And what happened to our x for our domain? Just f of x, nothing happened. So nothing is changed. This is negative 2. So the domain would remain the same. It's just f of x, right? But what is going on with the range? We have the range of negative 2 and 8. What is going on here? By dividing negative 2 and 8, 1/2 of negative 2 and 8, that would become negative 1 and 4, right? But it is translated down negative 6. That means you have negative 6 translated down. This will be negative 7, negative 2. This is the new range. All right. That would be the new range. Identify. Oops, I made some drawing here. Can I erase that? Okay. Let's have this number. Identify the parent function of f of x and write an equation for the function given. Okay. This is an absolute value. So the parent function for absolute value is, all right, parent function is the absolute value of x. Okay, so how are we going to draw the absolute value of x? When x is 1, the absolute value is 1. So it should be when x is 2, the absolute value is 2. So our graph looks like this. All right, I'm going to draw the graph of the absolute value of x. So the graph looks like that of the absolute value. Because when you draw your table, if you have 1 for x, the absolute value is still equals to 1. So what happened? How many space did it move to the right? 2 space. So we can write the g of x here. We'll write the absolute value. I'm doing the horizontal translation to the right, that means it's minus. And then how about the, let's say, this point and this point right here? 3. The scale factor is 1/3 because it's 3. And it's being stretched. Okay. This is a cubic function for number 2. So the parent function is, for cubic, f of x is x to the 3rd power. Okay. So if I have 1, let's say if I have 1, x is 1, y is 1. If I have 2, y is 8. If I have negative 1, it's negative 1, right? If I have negative 2, it's negative 8 for the cubic. So when we draw our graph, let's say we draw the graph for cubic function, it will be like that. So what happened is that this is a reflection of that across the y-axis. So that means the g of x, it's a reflection of the x cubed. All right? And this goes down by 3. So it's minus 3. Translated down by 3. Okay. Let's have multiple choice here. The function f and g are defined for all real numbers that are such that g of x is negative f of x plus 5. So there is a reflection, there is a translation, vertical translation, up and down. Okay. Which of the following transformations help the graph of f to the graph of g in the same xy plane? A horizontal translation of graph f by 5 units, followed by a vertical reflection of the graph of x. Vertical reflection or vertical translation, not a horizontal. You have a horizontal translation. It's not a horizontal translation. It has a vertical translation of graph by 5, followed by a vertical reflection. Vertical reflection? No. A vertical reflection of f followed by a horizontal translation of graph by 5 units. No. A vertical reflection of graph followed by a vertical translation of graph by 5 units. This is the answer. Vertical translation. Okay? Vertical reflection. This is vertical translation. Vertical reflection, but this is horizontal, so it's not. Function is given by f of x equals negative x squared plus 3x plus 2, the graph of which the following function is the image of the graph of f after a vertical translation, the graph by 4 units. So m of x is negative x plus 4 squared 3 times x plus 2 because it's additive transformation, that the result of adding its input values. No. N of x is negative x minus 4. It's the one that is x minus 4 because it's the additive transformation of f that results adding its input value of x. That's not the right answer. But if you have this, x squared plus 3x plus 6, because this is the additive transformation that the results adding to the function of x. Okay, this is the right answer here. Minus 2, no. All right, you have that. The graph of y equals f of x is shown from -3 to +4. This is 4. This is -3 right here. That is where the graph. Which of the following is transformed? Let's do the inside. The horizontal transformation. So that's plus. So 2 to the left. So from here, 2 to the left, the graph should be there. -1. So it goes down 1. So it should be, actually we have that already, the red one. And this would be the right answer here. Okay. So we have a very long problems and solutions for these transformations of functions. All right, let me say this. If I can do it, so can you. Please don't forget to hit the like button and please subscribe. See you in my next video.